All right, so this is part 2 of section 14.4 where we get to solve trigonometric equations. The first portion of it was we were going to isolate the trig function and be able to take the inverse of that trig function in order to solve for our degree or radians. Uh, in this section, part 2, we're going to be able to factor it by either factoring a common trig function or by using the quadratic formula. So being able to factor it is basically just like factoring a regular equation. So for example, if I had 3x squared plus 24x equals 0, how you would solve that is by taking, I could factor out a 3x, and then in parentheses, I would have x plus 8. Then from here, I could use the zero product property. The zero product property states that I could take 3x and set it equal to 0 and take x plus 8 and set it equal to 0. By solving both of these equations, I know that x here could equal 0 and x here could equal -8. By plugging both of those values in for x to see if those hold true, in this case both of them hold true, that's how you would solve equations with variables. Very similar, but instead of using variables, we're going to use trig functions. So, for instance, say we have a equation such as 2 times the sine cubed x equals sine of x. So from here, we want to get one side of our equal sign equal to 0. So I'm going to subtract sine to both sides. So I'm left with 2 sine cubed x minus sine x equals 0. So from here, I have a common trig function of the sine of x. So I can factor out a sine of x to both of these expressions. So I'm going to have sine of x on the outside of my parenthesis, set it equal to 0, and then on the inside it's going to be 2 times the sine squared x minus 1. And how I get that is if I were to distribute this and distribute this, it would get that portion of the equation. So that's where that comes from. So now from here I get to use the zero product property. So now I get to set sine of x equal to 0, and I get to set 2 sine squared x minus 1 equal to 0. For the first one, in order to get x as our value, we must take the inverse sine of 0, which will get x. And in this case, the inverse sine of 0 is 0. For my second equation, I must isolate my sine squared function. So I'm going to add 1 to both sides, so I get 2 sine squared x equals 1. Divide both sides by 2, so I get sine squared x equals 1/2. Take the square root of this, so I can get sine of x equaling plus or minus the square root of 2. But I can't have a square root be in my denominator, so the sine of x is going to equal plus or minus the square root of 2 over 2. Now this happens to be a trig ratio, and that means that if I take the inverse sine of square root of 2 over 2, I'm going to get x is going to give me pi over 4. So from here, since I have both positive and negative values of square root of 2 over 2, that means I'm going to get 4 solutions like I did in part 1. So from here, I can say that I take this first one with the sine of x equaling 0, means it's going to be 0 plus 2 times, or let's write it like this, even though it's the same thing, but let's keep it, so it's n times 2 pi, and then for the second equation, I can write it as pi over 4 plus n times 2 pi. Then, if I were to make a graph of this, I know that pi over 4, which is 45, is here, 45 here, 45 here, and also 45 here. So that means I can use 3 pi over 4 plus n times 2 pi. I can use 5 pi over 4 plus n times 2 pi. And then I can also use 7 pi over 4 times n times 2 pi. So these are my solutions for this particular equation. Okay? Here's another one. Let's say I have square root of 3 cosine x times tangent x minus cosine x. So now in this case, I have a common trig function of cosine of x. So that means I'm going to factor out a cosine of x. So cosine of x is on the outside of my parentheses. And then on the inside of my parentheses, I'm going to have square root of 3 tan x minus 1. Again, same process. If I were to distribute that cosine of x, I'd get what I'd had on the top. So now from here, I get to use the zero product property. So I go cosine of x equaling 0, and then the square root of 3 times tangent of x minus 1 equaling 0. For the first one here, I get cosine, the inverse cosine of 0, what happens to be 90 degrees, and also if I was in radians, it's going to be pi over 2. If I go to the other side of my equation, I'm going to add 1 to both sides, so I get square root of 3 tan x equals 1. Divide both sides by the square root of 3, so I get tan x equals 1 over the square root of 3, but I need to rationalize the denominator. So I'm left with square root of 3 over 3. And then this is a trig ratio. So if I were to take the inverse tangent of square root of 3 over 3, I would get 30 degrees, or pi over 6. Now, what makes this one a little bit different than from the other one is I want to check my solution. So if I were to plug in pi over 2 into this x, and this x, more importantly, what if I were to plug it into the tangent of x? So if I were to plug into my calculator the tangent of pi over 2, I would receive an error, which means it's no solution. So if x were to happen to be pi over 2, it would be no solution. So I can't use this solution in order to solve our equation. The only one that works is the reference angle of pi over 6. And again, so you're going to use the same steps as you used in part 1. You look into your chart, and it says that since this tangent here was positive, it's going to be positive in quadrant 1, and it's also going to be positive in quadrant 3. So I'm going to have my 30 degrees here, and I'm going to have my 30 degrees here. So I get to have my pi over 6 plus n times 2 pi, and then I also get to have 7 pi over 6 plus n times 2 pi. So those are the answers that are going to work for this particular problem. So that's how you factor out problems like this. If you're going to be using the quadratic formula, you're going to use the same steps as you were to use the quadratic formula in a regular quadratic equation, but instead of having variables, you're going to have trig functions. So if I look at example A, I have 2 times tangent squared x minus 3 times tangent x plus 1. So what's replacing our ax squared plus bx plus c format is, instead of it being x as our variable, it is a trig function. In this case, it's going to be tangent x. So, but the a, b, and c still stay the same. So my a here is still 2, my b is negative 3, and my c is 1. So at this point, we're going to plug it into the quadratic formula just like we were for any regular equation without a trig function. So I'm going to go, it's negative b plus or minus the square root of b squared um, minus 4ac all over 2a. So I'm going to go, so it's negative b, so it's the opposite of b, so it's going to be 3 plus or minus the square root of b squared, which is 9, minus 4 times a, which is 2, multiplied by c, which is 1, all over 2a, which is, it's going to give me 4. So from here, I get 3 plus or minus, that's going to be 8 times 2 times 1, that gives me 8. 9 minus 8 is 1. The square root of 1 is 1. And I divide that by 4. So I'm going to get a value of 3 plus 1 is 4. 4 divided by 4 is 1. And then 3 minus 1 is 2. 2 divided by 4 is 1/2. So this is where it changes, because before you would get x equals 1 and x equals 1/2. But because we're in trig functions, we now have to write it as tangent x equals 1 and tangent x equals 1/2. So now in order to find what this x value is, we must take the inverse tangent of 1 here. That will give us x. And we must take the inverse tangent of 1/2 here. So if we're going to take the inverse tangent of 1, we're going to get 45 degrees, or pi over 4. And then in this case, I'm taking the inverse tangent of 1/2, and that gives us 26.57 degrees. And if I were to convert that to radians, I would get something very close to roughly 0.46 radians. So in this case, with using the quadratic formula, my values are going to be pi over 4, comma, 0.46 radians. Okay? Let's give one more a try. Let's give this one a try. So from here, we have sine x as our variable in this case to help us solve the quadratic formula. But again, we have to get everything all on one side. So I'm going to say sine squared x minus 4 sine x here plus 2 and set it equal to 0. So that means my a is 1, my b is negative 4, and my c is 2. So I get to use the quadratic formula. So it's going to be 4 plus or minus the square root of 16 minus 4 times 1 times 2 all over 2. So now I get 4 plus or minus. So if I take 4 times 1 times 2, it's what, 16 minus 8, which gives me 8. And this is going to be the square root of 8 divided by 2. So 4 plus the square root of 8 gives me like 6.82. Divide that by 2. So that gives me 3.41. So about 3.41 as a value. And if I take 4 minus the square root of 8 and divide that by 2, I get something like 0.59 roughly. So, but this is where the change is. So now I know that the sine of x could equal 3.41, and I know that the sine of x could equal 0.95. So if I take the inverse of this one, so if I go inverse sine of 3.41, I get a domain error. So that means that this one has no solution. But if I take the inverse sine of 0.59, I get a value of 36, I'm sorry, 0.56 degrees. And then if I was to convert that to radians, I multiply that by pi and divide that by 180, I'll get a radian value of 0.63. Okay? And that is part 2 of being able to solve trigonometric equations. Hope this helps. Until next time.